Okay. So chapter 5 notes. Again, nothing really going on. Oh, shoot, I should probably screen share for the Zoom. Uh, that. All right. Um, chapter 5 notes. Nothing really crazy in the intro. Um, but yeah. So there's two effects that are in this chapter. The income effect, which is the change in consumer consumption choices that result from a change in purchasing power. So like if I start out with $10,000 and then I get $15,000 and everything else stayed the same, then my purchasing power went up because my income went up. Similarly, if I have $10,000 and the price of everything changes, like it reduces by half, um, then uh, I also get increased purchasing power because it's like if the price of everything is half, then it's like I have twice as much money because I have twice as much purchasing power as I did before. And then substitution effect is the change in consumption that results from a change in the relative price of goods. So this is when the price of one good changes and the other one doesn't. So the price of goods relative to each other is what that means. And then the total effect on the graph is just income effect plus the substitution effect. All right, normal goods. We kind of went over this in class, but um, basically consumption increases as income rises. So, if it's usually like things that aren't necessities, but your life gets better as you buy them, right? So if I really, really broke, can't even afford a car or anything, then I'm not buying a whole lot of gas. Um, but as I make more money, I'm going to be spending more on gas, more on car payments, more on insurance, stuff like that. Um, and then there's this concept called elasticity. Elasticity is like the tendency for uh, the demand of a good to change based on or based on the price of the good. So, for example, like water, right? Water's a necessity for everybody. People are going to buy it whether it's, 20 cents a bottle or if it's $2 a bottle. You're not going to get around doing it. And yeah, you can get water out of the tap or whatever, but like still just paying for water as an item, people are going to buy it no matter what the price is. So we would say for that, the elasticity is low. Um, because they're a necessity. Everybody buys them, doesn't matter how high your income gets or how low it gets, you need them to survive. Um, if elasticity is high, it means that the demand for that good is going to change a lot with the price. So the price is going to be very influential on the demand of the good. So, like, if I was, like for right now, I want those 42-gram protein drinks that are all over my TikTok shop right now, but I'm not going to pay $100 a case for them. However, if those go on sale for $60 a case, I'm gonna cop a couple of those um, because the elasticity is really high on those. The price determines if I buy that or not. I could go without having those protein drinks. I can get my protein in other places, but it's something I generally want. So if the price makes it worth it, then I'm gonna buy it. But it's not like if I'm down to my last $100, it's not going to those protein drinks. Um, so yeah, and then that brings us to inferior goods. So consumption decreases as income rises. These are mainly like budget items or yeah, mainly budget items. So like the big one is like ramen. Like as you get richer, you don't really spend a lot on the cheap food and stuff like that. Um, yeah. One of the examples you brought up in class was like bus tickets. So if you're like super broke and you can't afford bus tickets, um, then obviously you're not going to be buying a whole lot of them. You're just going to be walking or biking or whatever. So your demand for that is going to be really low. If you're in kind of this middle zone of like, I can afford bus tickets, but I can't quite afford, shit, I can't quite afford to own a car yet, then you're going to be buying a lot of bus tickets. And if you can afford a car and you don't need to drive the bus or you don't need to ride the bus anymore, then you're not going to be buying very many bus tickets. So it can fluctuate and goods can change. Like the good never changes. There's always bus tickets, but it can change from a normal good to an inferior good. My roommate is ringing the door. I gotta go for like 2 minutes. All right, sorry, they were being idiots. Um, So yeah, that's kind of what this equation does. It's the change in quantity over the change in income. So quantity is demanded, um, and that's how you get elasticity. So the income expansion path, these straight lines and these curved lines are the same stuff we learned about in chapter 4. So the straight lines are the budget constraints. So like if she spent all her money on bus rides or all her money on bottled water, that's how much she could buy. And then this utility curve, the same thing. And then we could use that to find the areas of best utility, and if we take that over different budget constraints, you see how there's like 5 different budget constraints here, and we find the best point of utility at each of those budget constraints, then we can plot a graph and it shows the income expansion path. So as income increases, this is where we're going to best maximize utility. We can look at the slope of this graph to determine a couple of things. So if both of the goods are normal goods, where consumption increases as income rises, then the slope is going to be positive. So like here it's positive, 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 until this inflection point at D. If the slope is negative, um, the the quantity of one falls while the other rises with income. And then the one that falls is inferior. Okay. Um, this is the Engel curve. It didn't really come up in the homework. I mean, there was a graph similar to this one, um, but it compares it only shows one item. So like on this graph, it shows 2 items. This one compares income to one item. So you can see it shows you like um, if it's an inferior good or a normal good for just one item. Okay, um, demand curves. Um, so it's the same graph from chapter 4 with the budget constraint and the utility graph. And then again, you change the price of one item basically. So this would be the price increasing. So with all my money, I could buy 20. But if the price doubled, then I could only buy 10. If the price doubled again, then I can only buy 5. So that's why these budget constraints are more steeply angled. And then we find the maximizing utility, and then we plot a line over those 3. So that's how we're finding our demand curve. And this kind of it's it's really um, it doesn't make a whole lot of sense until you start applying it. So that's why I'm kind of um, it's like just going over this and not really going too far into depth because I think it's better to just do it with the homework. Um, but yeah, and then shifting demand curve, um, you can shift it by it's the what's going on here? I don't remember this part. Oh well. It probably isn't on the homework. Um, this part definitely was on the homework. So this isolating substitution effect. So remember the substitution effect from up here, the change in consumption that results from a change in the relative price of goods. Um, this one we have a couple problems on, so it's important to know how to do this. Um, so, like I said, we have the two budget constraints, right? Budget constraint one, budget constraint two, utility curves, and kind of the point where we're maximizing utility. Um, so let's just look at the first one. Um, okay, so the substitution effect is on, obviously it's on both items. We have this A right here. This is the original, like maximizing utility is point A. Okay, as we move to budget constraint one, yeah, as we move to budget constraint one, A moves to this like A prime. Okay, so and this A prime is going to be on the same utility curve. So you see how this budget constraint line is not touching A prime. It's just at a different point on the utility curve. So the difference between A and A prime is a substitution effect. So you see this dotted line right there, and then A prime, that dotted line. So the difference between those two is substitution effect. And the same thing up here, okay? But this one's actually going to go like down. So the difference between A and A prime, that's the difference between 5 and 3. So the substitution effect here would be 2. Substitution effect here would be 1. Okay. Income effect is the difference between A prime and B. Okay. So this dotted line and this dotted line. So we can see it's 4 to 5. Income effect is 1. A prime to B up here. So 3 to 6. That would be 3. Okay. And then you can add these up. You can also do like if you already knew the total effect, you can, subtract the income effect and get the substitution effect. Like it works like that if you want to do it. But either way is how you get to it. So the difference between A and B would be the total effect both ways. So you can see that like there's between A and A prime here, it would be a -2. But then the difference between A prime and B would be a +3. So -2 plus +3 is a +1, right? So this to this would be a +1, this total effect. And like I said, that's going to come up a couple of times on the homework. This one was just like a wacky little, it was like a tidbit. I don't know what to call it. It didn't come up in the homework, and I think it was just there to like a little fun fact or whatever. I don't know if we're going to be tested on it, but let's see if I can find it. Yeah, it had like a little thing down here, but it didn't really seem all that important. These are substitutes and complements. We touched on this a little bit in chapter 4, but it shows, and there's nothing in the homework for this. Or, you know, there is a little bit in the homework for this. I take that back. But anyways, so if you have substitutes, the best example I can come up with is like, Coke and Dr. Pepper. And, a lot of people have preferences on one or the other. I don't really care. So to me, they're substitutes. So, when I go to the store and I see, Diet Dr. Pepper is, you know, 10 cents cheaper than Coke Zero at HEB or whatever, then I'm buying the Diet Dr. Pepper because in my eyes, they're perfect substitutes. I'm not too picky. I just want a Diet Cola. That's it. So if there's an increase in the price of Coke, then I'm more likely to buy Dr. Pepper. And the opposite is true. So if there's a decrease in the price of Dr. Pepper, then I'm more likely to buy Dr. Pepper and less likely to buy Coke. So complements would be the opposite of this. So it would be like chips and queso, or the perfect complement would be like left shoe, right shoe. So if I was buying guacamole, right, and there's a decrease in the price of chips, then that's going to increase my demand for guacamole because I'm like, oh, I'm getting a good deal on this. But if there's an increase on the price of chips, then that's going to decrease my demand for guacamole because like I can't have my guacamole without my chips. Um, Last thing is market demand. I don't think there's anything on the homework for this, but it just showed you how to calculate it. Um, so it's the same demand. Um, we've been doing a lot of individual demand. All you have to do is like add them together, and then you get this sloped line. There's a reason that it like kind of kinks up right there. It's because of like at a certain point, I'm not going if it's not a necessity good, then I'm not going to spend more than a certain amount on something, right? So um, if what's it called? Back to the protein drinks. If protein, the chocolate milk protein things, if they're more than, 4.50 a bottle, I'm not going to buy anything, but if they're like $2 a bottle, then I'm going to buy a whole lot of them. Um, so I would be on this A curve right here, right? Um, and then my friend, he's got a little bit more money. He's like, okay, anything under $5 a bottle, I'm gonna buy. Okay, so he's gonna take over this kind of part. So this would be just his demand curve, and this A part would be an average of R2, right? Because my cutoff is $4. I don't want to spend more than $4. Um, but he's willing to go up to $5. So that's why this demand curve is a little steeper here. All right. Everybody's favorite part, the homework. Actually, I guess I should ask if there's any questions. Probably not.
Wait,
Um,
one
yeah,
second.
go for it.
Okay, so you said that the income expansion path is a curve that like connects all the like utilities at that quantity or
Yeah, so what you're doing is you're changing the income, right? So
Mhm.
we started in chapter 4, we looked at just like one income by itself. There was only one like line here and one
Mhm.
utility curve. This is like so this would be if I only had $10, this would be my maximized utility. But if someone gave me $20 or $30 or $40 or $50, then this would be how I would maximize my utility at each of those price points. So
Okay,
like
okay.
each of these green lines is a different amount of income that I have, and like each of these like utility curves is the way I would
Mhm.
maximize utility at each of those incomes.
Okay. Yes. Thank you.
Yeah. All right. Homework. Again, this one was a little tricky, just because the elasticity is 0, so I didn't really know how to answer this. Because you can see he buys 16 ounces of salt each year, and even when the price of salt doubles, he continues to purchase exactly 16 ounces. So the price had no effect on his demand. He still bought the same exact stuff. Um, So, and I also didn't get it because the textbook gave a what's a an example of a normal good, and they said toothpaste or salt. So this made me think it was a normal good, but um, I don't know. The homework didn't agree with the textbook at this point. So it's an inferior good because the income effect is positive, which I also don't agree with because the income effect is 0. Um, it says the price elasticity for demand for salt is 0. That's good. For Brady, salt has a negative effect, negative income elasticity of demand, which I also don't get because it should be 0, because it doesn't change. Um, and these ones, since it's 0, they have the same magnitude, which is the distance from 0. So like it would be like +1 and -1 or something, or like +2 and -2. But they have opposite signs, so they cancel each other out to make 0. All right, this one, all you do is plot the points on the graph. So 5, 5, 10, 6, 20, or 15, 20. That one's pretty easy. And then you get into looking at the graph. Um, so books are a normal good for Alice. income ranging from blank to blank. So normal goods, they have a positive like consumption to income. Um, so anywhere where it's a positive slope is going to be a normal good. So that's positive slope, that's positive, that's positive, that's positive. Then it goes back to a negative, right? So we're going to take the income, so it's 5,000, and then 25,000, so 5,000 to 25,000. Books are an inferior good, which means that consumption decreases as income rises. So income's still rising, but consumption is decreasing. Um, and that happens from 25,000 right here to 50,000 up here. Luxury good is a good that has an income elasticity greater than 1. Books are a luxury good for Alice for income ranging from blank to blank. So we're looking for high elasticity, which means the price really, really affects it, either going up or down. So we look at the difference from her having $5,000 or $10,000. So if she has $5,000, she's going to buy 5 books. She has $10,000, she's going to buy 6 books. So not a whole lot of change there. But if she gets an extra 500 or $5,000, then she's going to buy 20 books, right? That's a 14 book change right there. So that's pretty elastic. This one would be negative elasticity. So it'd be like the inferior good. I don't know why books would be an inferior good. I see a lot of rich people with like massive bookcases, but oh well. It says it's an inferior good. So the best elasticity we have for normal good would be right here from 10,000 to 15,000. So 10,000 to 15,000. All right. These are a bunch of graphs. This is where the where is it? This isolating substitution effect is going to come in handy. Um, so you're going to want to do the graphs. Maybe I should have like waited to do it so I could still move these around. But anyways, they all have an income of $30 and they pay $2 for apples and $3 for peaches, right? So they can either buy this original blue line, the BC1 was already here, right? So they can either buy 15 apples or 10 peaches, right? And it asks you to place the new curve labeled NBC, which is if the price of peaches falls to $2. So now they can buy either 15 apples or 15 peaches. So you would write 15 apples and 15 peaches for this NBC, right? And you'll see that it intersects with this point here on utility curve too. And you do that for all of them. So all of them can either buy 15 apples or 15 peaches. All right, and then you look at the total effect of price change. So you see the new utility curve is going to be at 9 and 6. And that's a change from BC1. So I think it's indicate how many peaches they would buy. So we're not looking at apples, we're just looking at peaches. So we have from BC1 to, oops, from BC1 to NBC, that'd be 1, 2, 3, 4 peaches, 4 peaches. And then from BC1, this utility curve, we're at 5 peaches, and then we're trying to find this one, it goes here, so that's just 1 peach, 1 peach. And then TED, from BC1 to NBC, that's again just 1 peach. All right, so 4, 1, 1. But remember that's total effect. So to find the substitution, we have to remember this. So it's the change from like A to A prime. So you kind of figure out what A prime is. Remember, it's the same point, or it's not the same point. It's on the same utility curve, but it's not touching BC1. Or yeah, it's not. So this BC1 line, tangent to right there, which means it like it's um, parallel to the slope at that point. But you can see the only thing that this is touching is U1 because this HBC line comes in later. That that doesn't come in until like down here. So pretend it's not there right now. But anyways, this is the price we're looking at. So it's the difference between this and this. So 5 to 6, that's one peach. Um, from this to this, 5 to 7, that's two peaches. Yeah. And then from this to this, that's one peach right there. And then from this, you can either find the difference here, or you can do it on the graph. Doesn't really matter. So you can say 4, or you have 1 from substitution. So what do I need? I need 3. And then I'm at 1, I'm at +2, but that's too high, so I need a -1. I'm at 1, I'm right where I need to be, so I don't need to do anything. In other words, you can also go from A prime to B. So it'd be A prime here, so A prime, 1, 2, 3 peaches, and that's here. And then this is A prime to B, so that's -1 peach right there. And then we're at A prime to B, there's no change. So it's a 0. And then you draw the HBC line, which is, it's a hypothetical budget constraint. And what you're doing is you're just drawing a line tangent to this A prime. Tangent, like I said, it just means it's parallel to the slope at that point. So you're drawing a line that goes through that point. And you wouldn't draw it like here. Um, you wouldn't draw it from like there to there, because even though it passes through that point, it's not like along the curve, if that makes sense. Let me see if I can tangent line, just so everybody gets this. It has to be like along the curve. Um, so it wouldn't be like jutting off that way. So, but yeah, that's how you do that. For Bob, they are normal. Um, for Carol, they are inferior. I guess we can go back to definitions. And for Ted, they are an income inelastic. All right. So this one, it changes from them being perfect substitutes to perfect complements, and it's more graphing. So it tells you to initial equilibrium. So BC1, it gives you BC1, decrease in the price of calzones because the budget constraint to rotate from BC to BC2, reaching the higher utility curve U2 where optimal consumption occurs at B. Right, so originally with BC1 and utility 1, those intersect at A. Now with BC2 and utility 2, they intersect at B. Okay, move the hypothetical budget line BC prime, this one, to its correct position to show the substitution effect. So substitution, number 1, they should be 100% equal, because they're equal in price. So yeah, it should be the same at both. Um, so you could either buy 9 pizzas or 9 calzones. And I wish I could move this to show you the dots, but it was just process of elimination. You knew it had to hit at A prime, and then the only thing that was equal to A prime over here was 9. So yeah. Now suppose they are perfect complements. It changes from BC1 to BC2 again, and then the optimal consumption is now at B. So it moved utility curves. Move the hypothetical budget line BC prime to its correct position to show the substitution effect. So BC prime here, 9 and 9 again. I really wish I could go back and show you because I kind of just used process of elimination to get this. I didn't really think about it in the way that I guess they were trying to get me to think about it. But yeah, this is the right place for it. Um, and it's fully accounted for by the income effect. This is something that should be a little bit more familiar. It doesn't have these wacky straight lines. Um, but anyways, it moves from BC1 to BC2, asks you to plot this line. Again, we're doing a line that's tangent to A prime, and it goes through, you just want it to be tangent to A prime. And again, it's going to be at 9 and 9. All right. This one, you can see that pens will write, they're perfect substitutes. You know that because the utility curves are straight. Um, but he considers pens to be 1/5 that of pencils. So pencils are 5 times better than pens in his mind. So you draw these utility curves where 5 pens is the same as 1 pencil, 10 pens is the same as 2 pencils, and 15 pens is the same as 3 pencils. I think those are the only three combinations where it's like 1 times 5 to get to 5, 2 times 5 to get to 10. Um, and then you plot, so those are the three utility curves. Um, so he has $10 to spend on pens and pencils, and they each cost $1. So that's this line right here. It goes from 10 to 10 because he could either buy 10 pens or 10 pencils. Um, and then you'd find that utility curve that it matches up with would be right there. Um, Using the prices and income, plot Mitch's budget line BC1. So this is BC1 right here. It kind of cuts off. Wish I could. There we go. This is BC1. Why can't I? I'm gonna scroll sideways. I promise it says BC1 over here. And then it says, what if pens and pencils now cost $10 each? So he could only buy 1 pencil, but he could still buy 10 pens. And you can see the highest utility curve would be this one, where he would be buying 10 pens. All right, so if the price of a pencil is more than 5 times the price of a pen, he will purchase only pens and no pencils. Um, because it doesn't make sense. Like pencils are only 5 times better than pens. If they cost more than 5 times as much, then it doesn't make sense to buy them. And if it's less than 5 times the price of a pen, he will only purchase pencils because it's what it makes sense to do. This one I left open because it was getting a little crowded, and I figured it'd be hard to explain, but I'll go through it. All right, so $48 each month on Oreo cookies. Which cost $2 a package, and chips, which cost $3 a bag. So we're going to plot BC1. So take BC1. $48 on Oreo cookies means you can buy 24 of them. And then $3 a bag for chips means you can buy 16 of them. That's BC1 plotted. Suppose at current prices, she purchases 6 bags of chips per month. So we're going to place point A. It's 6 chips. A, 6 chips is right there. Move the indifference curve, view 1, to match that. And she buys 15 packs of Oreos. New price of chips is $2 a bag, so she can buy the same amount of Oreos, but she can now buy 24 packs of chips. She's got $48, $2 a bag. You can buy 40 or 24 of them. And she increases her chip consumption to 8 bags a month. So we're going to take B here, and we're going to go 8 per month, and she'll be buying 16 things of Oreos. We also need to put the utility curve there. Okay. And then chip producer catches on fire, and now the price of chips is $4. Yikes. Oreos didn't change. She can now only buy 12 things of chips. and she goes to 5 bags a month. So we're gonna go 5 bags of chips per month right there, and then we're gonna place our utility curve right there. How many Oreos? She's buying 14 Oreos. All right, now we just have to plot how many chips she brought, or how many chips she bought versus the price of the chips. So at $2 a bag, she bought how many? What was it? $2 a bag, 8 bags of chips. So at $2 a bag, she bought eight. At $3 a bag, where was that? 6 bags, I think. Yeah, $3 a bag. She bought 6 bags. Um, six, and then when it caught on fire, $4 a bag, and she bought 5 bags. 5 bags of chips, $4. Hopefully this is right. I'm gonna look really dumb. Awesome. All right. Um, that's that. Do you guys? There's seriously only one person here. Yikes. Um, do you have any questions?
I don't think so. You explained stuff really well, so thank you so much.
Oh, no problem. Okay. I'm gonna end the meeting and end the video. So I guess thanks for being here.